Hello everyone, welcome to my channel Smiley Creations. Today we are going to learn about Introduction to Problem Solving. Whenever we face a problem, we need to think about it, how to solve it step by step. Similarly, when we want a computer to solve a problem, we have to give a proper sequence of instructions. So in programming, we first understand the problem, prepare a solution, and then write the program. So let us start. What is problem solving? Problem solving in programming means finding a proper method to solve a given problem using computer. There are mainly three important things we do. Identify the problem, develop an algorithm, implement the algorithm. For example, suppose find whether a number is even or odd. So we first understand the problem, then create an algorithm, then write a Python code. Now let us understand the word algorithm. An algorithm is simply a step-by-step procedure to solve problem. Think about a cooking recipe. Recipe tells us what to do first, second, third, and so on. An algorithm works in the same way. For example, to add two numbers, we need to start, input two numbers, add the numbers, display the result, and then stop it. These are the important steps of an algorithm. An algorithm should not continue forever. It must eventually finish. Not every collection of steps is a good algorithm. A good algorithm should have certain characteristics. First one, precision. Every step should be clear and exact. For example, don't write, do some calculations. Instead, we write add A and B. There should be no confusion about what to do. Second one, unambiguity. Each instruction should have only one meaning. Different people should understand the instructions in the same way. For example, take some water. So how much? So instead that take 500 ml of water, which is clear. Third one, finiteness. The algorithm must eventually stop. It should have limited number of steps and should not continue forever. For example, finding the sum of two numbers will finish after a few steps. Input. Input means the information or values given to an algorithm. For example, to add two numbers, input A is equals to 10, B is equals to 20. Output. Output is the final result produced by an algorithm. For our example, output is 30. Effectiveness. Every step should be actually be a possible to perform. The instruction should be simple, practical, and executable. Easy way to remember is PUFIOE, that is precision, unambiguity, finiteness, input, output, effectiveness. This is an easy way of remembering the things. Now let's take a real example of an algorithm. Our problem is determine whether the given number is even or odd. So let us start. Step 1, start. We begin the algorithm. Step 2, input. We ask the user to enter a number. For example, number is equals to 8. Step 3, divide by 2. Now we divide the number by 2 and check the remainder. For 8, 8 is divided by 2. The remainder is 0. If the remainder is 0, the number is even. If the remainder is not 0, the number is odd. Step 4, output. For 8, number is even. Step 5, end. That is, the algorithm finishes. Important programming concept we must learn here. In Python, we use modulus operator, percentage operator to find the remainder. An algorithm is written using words or statements, but sometimes it is easier to understand the algorithm using a diagram. This diagram is called flowchart. A flowchart is a graphical representation of an algorithm using different symbols and arrows. Why do we use flowcharts? Flowcharts help us understand what happens first, what happens next, where is the decision made, what is the final result. Think a flowchart like a map. A map shows us which direction to take. Similarly, a flowchart shows us the flow of a program. This is an important exam topic. There are some standard symbols used in flowcharts. Each symbol has a specific purpose. Oval. The oval represents the beginning and ending of the flowchart. Rectangle. The rectangle represents processing information. Parallelogram. Parallelogram is used for input and output. Diamond. The diamond represents the decision or condition. Arrow. Arrow shows the direction of a flow. They tell us which step comes next. Now this is a flow chart to add two numbers. First we take two numbers from the user. For example, a is equals to 10, b is equals to 20. Sum is equals to a plus b. This is a process so we use in a rectangle 10 plus 20 is equals to 30. Display sum. We display the answer. The output is 30. And notice how every symbol has a specific job. The oval starts and ends the flowchart. The parallelogram takes inputs and display output. The rectangle performs the calculation. This is a very good example because it introduces a decision. Suppose we have two numbers, a is equals to 25, b is equals to 15. We want to find the number is larger. So step 1, we begin. Step 2, read a and b. We take two numbers. Step 3, decision. We ask if a is greater than b. This is a question, so we use the diamond symbol. If a is greater than b, print a. For for our example, 25 is greater than 50. So yes, therefore largest number is 25. If no, if a is not greater than b, print b. For example, a is equals to 10, b is equals to 20. So 10 is greater than 20. No, therefore largest number is 20. So here, whenever you see a condition or a question, think about the diamond symbol. Now I explain why we use algorithms and flowcharts. It is easy to understand. Algorithms and flowcharts present the solution step by step, so they are easy to understand. Easy debugging. If there is a mistake, we can examine the steps and find where the problem occurred. This makes debugging easier. Documentation. We can save the algorithm or flowchart as a documentation. Later, another programmer can understand how the program works. Better communication. A flowchart can make it easier for teachers, students, programmers, and other team members to discuss the solution. Students, before writing an actual program, we first need to think about the steps required to solve the problem. Pseudocode helps us to write these steps in simple English. Simple language independent description. Pseudocode explains the solution using simple English like statement. For example, input two numbers, add the numbers, display the result. It is not Python, Java, C++, or any other programming language. It is easy to understand. Even a person who doesn't know the programming can understand pseudocode because it uses simple words. No strict programming rules. We don't have to worry about brackets, semicolons, indentation, or programming syntax. This is pseudocode. The exact syntax can be different in Python or other language. Used to plan the logic. Before coding, we can first decide what is the input, what processing should be done, what should be the output. It helps solve problems systematically. It makes us follow the solution step by step instead of directly jumping into the code. This is an example of pseudocode to add two numbers. Begin. This tells us that our algorithm is starting. Next input a comma b. We ask the user to enter two numbers. Then here we add the two numbers. The arrow means assign the store that value. Print sum. Now display the answer. Then algorithm finishes. So here there are several advantages. So I'll explain them one by one. Easy to understand. Pseudocode uses simple English like language. Input marks, print marks, student can understand easily. Easy to write. There are no strict syntax rules. In a programming language, we must follow exact rules, but in pseudocode, we can write the steps in a simple way. Language independent. This is very important. Pseudocode is not dependent on Python, C, C++, or Java, etc. The same pseudo can be later converted into different programming languages. Helps in planning. Before writing the actual program, we can prepare the logic using pseudocode. Helps detect logical errors. We can check the steps before writing actual code. For example, if we forgot to take input, we can identify the problem while checking the pseudocode. Easy to convert into code. Once the pseudocode is ready, converting it into an actual programming language has become easier. Useful for communication. A program can explain the logic to another programmer, teacher, student, or even a non-programmer using pseudocode. Remember these three important things about pseudocode. Pseudocode, plan a program. It uses simple English-like statement. It helps us to understand logic before writing the actual code. Hope you like this video. Subscribe for more updates.